Imagine you wake up 10,000 years ago. No sense of direction, just a strange itch telling you to build GPS. It wants to tell you exactly where you're standing, to within 10 feet. It needs, in order, a coordinate system for the whole planet, a way to measure time so precisely that being wrong by 1 billionth of a second matters, a way to throw objects into orbit and keep them there, a way to talk to those objects using something you can't see or touch, a correction for the fact that time itself moves differently depending on how fast you're going and how deep in a gravity well you are, and a chip small enough to fit in your pocket that can do the math faster than you can blink. You are about 2,300 years away from that box existing. Let's start digging. First problem, there is no where. You need a grid. Around 240 BCE, Eratosthenes, sitting in Alexandria, notices that a stick in the ground casts a different shadow angle there than a well he's heard about in Sion casts at the same moment, and from that shadow difference alone, he estimates the circumference of the entire Earth to within a few percent using nothing but geometry and the very confident assumption that the sun's rays arrive parallel. A century later, Hipparchus takes that spherical Earth and starts drawing lines on it, the first latitude and longitude grid, so that where can finally be turned into two numbers instead of a shrug and a pointed finger. You now have a coordinate system. You, being the genius you are, don't even blink. You still have no way to find your two numbers unless you're standing next to Eratosthenes' well. Second problem, even with a grid, you can't fix a position without a clock, and not a sundial and a prayer clock, an obscenely accurate one. Sailors figured this out the hard way for centuries. Latitude is easy, you just look at the stars, but longitude requires knowing the exact time back at some reference point, while also knowing the exact time where you are, and clocks on a rocking ship lose minutes a day. It takes until 1761, when John Harrison finishes a marine chronometer, accurate enough to hold time across an ocean crossing, for longitude to stop being a guessing game that got sailors killed. Good. Now you can find yourself on a map using string, patience, and a very expensive clock. You are still nowhere near GPS because your clock is only accurate to the second, and GPS needs accuracy to the billionth of a second, because radio waves move so fast that a clock error of 1 microsecond translates to a position error of nearly 1,000 feet. Third problem. You need to send and receive signals without wires, which means you need to understand electromagnetism as a real physical force and not a party trick. Michael Faraday spends the 1830s showing that electricity and magnetism are related. James Clerk Maxwell spends the 1860s writing the equations that predict electromagnetic waves ought to exist and travel at the speed of light. Heinrich Hertz spends 1887 actually producing and detecting one in a lab, mostly to prove Maxwell right, and famously assumes the discovery is useless. Guglielmo Marconi disagrees, and by 1901 is bouncing radio signals across the Atlantic Ocean. You can now talk to something without touching it. This part's obvious to you. You just need something worth talking to. Fourth problem, that something needs to be in the sky, and staying in the sky on purpose is its own several century project. Isaac Newton works out in the 1680s that an object thrown fast enough sideways will fall toward the Earth at the same rate the Earth curves away beneath it, forever. That's an orbit. It takes until the early 1900s for Konstantin Tsiolkovsky to write the rocket equation that tells you how much fuel you'd actually need to reach that speed, and until the 1920s for Robert Goddard to fly the first liquid-fueled rocket, which goes about 40 feet in the air and is considered a triumph. Wernher von Braun's V2 program in the 1940s finally built something that can leave the atmosphere on purpose, and in 1957 the Soviet Union straps a beeping metal ball called Sputnik to a modified missile and puts the first man-made object into orbit. You now have somewhere to put a satellite. You do not yet have a satellite that can tell anyone anything useful. Fifth problem, and this is the one that actually breaks people's brains. To find your position, a GPS receiver doesn't get told, "Here is your location." It measures how long a signal took to arrive from 4 different satellites at once, and does the geometry backward. It only works if the satellite's onboard clock is accurate to the nanosecond, because light in radio travels about a foot per nanosecond, so a clock error of a millionth of a second is a position error of 1,000 feet. In 1955, Louis Essen and Jack Perry built the first accurate cesium atomic clock, which counts the vibration of a cesium atom over 9 billion times a second and barely drifts at all. Now you have a clock good enough to do the math, except your clock is still wrong, because of something nobody saw coming until Einstein. A satellite is moving fast, which slows its clock down under special relativity, and it's sitting in weaker gravity than the ground, which speeds its clock up under general relativity. Net effect, an uncorrected GPS satellite clock drifts about 38 microseconds a day compared to a clock on the ground. That sounds small. Left uncorrected, GPS positions would be off by about 6 miles after a single day, getting worse every day after that. Someone has to bake Einstein's equations directly into the satellite's onboard software, just so the system doesn't drift into uselessness by dinner. Last problem, all of that math, solving for position from 4 signals, correcting for relativity, updating 30 times a second, needs to run on something you can carry. That means the transistor, invented at Bell Labs in 1947, and everything that follows from it. Integrated circuits, microprocessors, a chip that can do in a fraction of a second what would have taken a room full of mathematicians a week. The U.S. Department of Defense launches its first working GPS satellite, Navstar-1, in 1978, and by 1995, the full 24 satellite constellation is declared operational. 2,300 years after a man with a stick in his shadow, you can finally hold a box that knows exactly where it is, anywhere on Earth, at any time, whether you deserve to know or not. So, what does everyone actually do with it? The chief gets his hands on a receiver first, obviously, and within a week, every field boundary in the valley has been remeasured down to the foot. For generations, boundary disputes got settled with a stick, 2 witnesses, and whoever shouted louder. Now the chief scribe walks the property lines with the box held out in front of him like a divining rod, and 3 families discover they've been farming 6 extra feet of somebody else's land for 40 years. Nobody is happy. The tax assessments go up. The box did not make anyone richer. It just made lying about your fence line significantly harder. Meanwhile, the man who used to navigate the trade caravans by memorizing star patterns and the smell of the wind is out of a job. His replacement is a 19-year-old who can read a glowing number off a screen and has never once looked at the sky for longer than it takes to complain about the weather. The old navigator sits in the tavern telling anyone who listened that the box will fail in a sandstorm and then where will they be, and everyone privately agrees he's right and hires the 19-year-old anyway. Nobody is any good at using it yet, either. A farmer sends his son to fetch a plow from the next village over, a walk he's done 100 times blind, and the boy spends 40 minutes standing at a fork in the road waiting for the box to recalculate because he no longer trusts his own feet over the glowing arrow. Merchants start bragging about the exact coordinates of their storefronts, the way they used to brag about bloodlines. A man plants a flag at a patch of scrubland exactly 1 foot past the edge of his neighbor's claim just to see if anyone will notice, and spends the next 2 years in the world's pettiest ongoing legal dispute over a strip of dirt nobody wants to farm. But the box's real career is in catching liars. A trader named Idra tells her husband she spent the afternoon at the Riverside Market. Her husband, who bought a receiver from the same merchant who sold him his plow, quietly notes that her position logs place her at their neighbor's house for 3 of those hours, 40 feet from the market she claims to have visited. He says nothing that evening. He brings it up in front of both families at the harvest gathering, holding the little box aloft like a legal document, reading her coordinates out loud to a stunned crowd while she tries to explain that near enough to the market isn't a crime. It isn't, technically, but nobody in that valley ever again trusts a story about their afternoon without checking the box first. And for the first time in human history, being somewhere you shouldn't have been becomes a matter of public record instead of a rumor. Idra never quite lived that afternoon down. Subscribe so yours doesn't end up on a box either.